In our second tutorial, we're going to model the wheel. First of all, go to the application button and create a new file. We're going to select a standard millimeter IPT file and choose create. Now, having already modeled the tyre previously, we know that when we first of all sketch this part, the outside diameter must be 70 millimeters. So select create 2D sketch from the ribbon, and from the appearing datum planes we're going to select this first datum plane here to create our sketch. Click once and the orientation will rotate round to our 2D view. Select the circle tool from the ribbon, click to the center with the green dot so that it snaps to position, drag out and enter a value of 70 millimeters and hit enter. Now resize. First of all, what we have is our outside circle, and this is now ready to finish the sketch, and we can extrude from the top ribbon or with the shortcut E, and we're going to extrude this part again 24 millimeters in thickness. What we're going to do this time, however, before we select OK, is to extrude symmetrically in both directions, and this will become clear later on. Select OK. Now that we have our first solid extrusion, we're going to remove material. So what we're going to do now is on the top surface we're going to create a sketch. Initially, using the line tool, draw two lines in the top left quarter of this circle. These two lines are green because they're not constrained or dimensioned. Use the arc tool and join these two lines up. Again, not too worried about the dimensions at this stage. Right click and go OK. What we're now going to do is we're now going to add some line work in to help us constrain and dimension this part. First of all, choose the line tool from the ribbon and move along to the format options and choose construction. What we're going to do is create two construction lines to the center of this circle. So as I've constructed here, we now have two construction lines joining our two drawn green lines. Again, using the line tool, we're then going to create a third construction line running up the center to the edge of the circle. So now we should have a construction line here along the center and two connecting to our drawn green lines. Why have we done this? Simply, this allows us to now make sure that these green lines will directionally travel towards the center, and we're going to use the following constraint. We're going to use the collinear constraint. This will mean that when I click this green line and this construction line, the two now run in sync. We do the same here, and we can now see that these lines run to the center. If we now try to adjust any of this line work, the lines are locked towards the central point. What we now need to do is constrain these curves. Using this constraint, which is the concentric constraint, click on the outside arc and to the outside of the circle. This means that this curve will now match the profile of this curve here. We're going to do the same to the inside arc and the outside arc now. Right click, click OK, and what you'll see is if we drag these points out, the arcs now run parallel to the outside circle. So no matter where we move these points, we now have constrained arcs and constrained edges. What we now need to do is start to add dimensions. What we're going to do initially is use the dimension tool from the ribbon, and we're going to add a dimension from this edge to this construction line that we created. We're going to drag up and enter a value of 30 millimeters. Our next dimension will be from the construction line down to the exterior edge and drag up. This will measure at 55 millimeters. Hit enter. We've now dimensioned these two positions along the outside perimeter. What we're now going to do is we're going to remove this middle construction line by clicking on it and hitting delete. What this now allows us to do is to change the position of this dot here and hopefully to modify the shape that we're creating. Using this tool here under constraints, it's a coincidence constraint. We're going to make sure that the corner here and this construction line tie together. So what we can now see, that as we move the line work around, we've managed to constrain and dimension some of the key elements of this line work. With this now in place, we can zoom out. Before I can finish the sketch, I need to make sure that all lines are fully constrained and dimensioned. At present, the only line that is constrained and dimensioned correctly is this blue line here. The green lines are not completely dimensioned or constrained yet. So I'm going to choose the Dimension tab from the ribbon, click the outside arc, drag out and set this to a dimension of 30mm, hit enter. The inside arc I'm going to click and drag out and set this to a dimension of 20mm and hit enter. What you can now see is that the line work has turned to blue, which confirms that it is completely constrained and completely dimensioned. We can now finish the sketch. With our sketch now complete, we're going to use the extrude button and choose the profile of that cut. We're going to choose to remove from the pop-up box, which is the second option down, and the distance will go all the way through the model. Click OK. We've now created our first hole through the wheel. At this stage, it's worth applying a fillet from the top ribbon of 2mm to each of the internal edges of that cut. As you can see in the preview here, we've now rounded those corners off. Click OK. With our first hole, we're now going to create a circular pattern to create the final holes around which the wheel will be constructed. From the top ribbon, under Pattern, select a circular pattern. Under Feature, select both the hole and the fillet by clicking twice, and for the rotation axes, on the left hand side under Origin, scroll down through the X, the Y and the Z axis and choose which is the appropriate. In this instance, the Y axis is the most appropriate. What we now have is a preview of the pattern we're about to create. Under Placement, we can change the number of cuts we're going to create, but in this instance 6 is correct. So we're going to click OK. We now have 6 corresponding holes which now create a pattern on our wheel. Having done this, we're now going to create a hole down the centre onto which the axle will spin. On the top ribbon, choose the hole option. Click onto the surface and you'll see instantly a preview of a hole appearing that is 3mm. What we're going to do is increase this hole to 22mm, and for references we're going to use the first reference only. Click on it from the pop-up and we're going to reference the outside edge of the wheel. What this has done now, it has centered within the outside perimeter the hole that we're cutting. Again, make sure that we're going all the way through the part and click OK. We now have a hole through the center of the wheel. Next, we're going to create a slight recess within which we're going to fit some bearings. To do this, on the top surface, we're going to create a sketch. Use the circle tool as we have done previously, and this time draw a circle from the center that is 30mm in diameter, hit enter and finish the sketch. This time we're going to use the extrude tool, select which we're going to remove, choose again to remove the material, and this time enter a value of 10mm. This will mean that we don't cut all the way through. Rather than flipping over the wheel to draw a second hole and cut a second hole into which a bearing will fit, what we're going to do in this instance is actually mirror that first feature. So under pattern there is the option to mirror, select mirror, and now choose from the left hand side or from the model the feature which you want to mirror. In this instance it's my extrusion 3 which has created the cut. In the mirror plane, from the origin options we have a YZ, an XZ and an XY. In this instance what we want to do is we want to mirror in the XZ plane, and when we click this, as you can see, this is the central plane. This brings us back to the first part where we created the extrusion and extruded it in both directions. So now it means we can use this central plane to mirror features on the top onto the bottom of the wheel. Select OK, and what we should see on the other side now is a corresponding hole that is mirrored on both sides. One of the final features we're going to create is we're going to create a revolution which is also a cut. To do this, we're first of all going to locate a datum plane onto which we can create a sketch. In this instance I'm going to choose the XY plane. Choose from the ribbon to create a sketch, and what we're going to do this time is we're going to choose from the ribbon under project cut edges. We're going to make sure that this option is selected, and as you can see some line work has now appeared. Under the top tabs we go to view, and under visual style we're going to look at the model as a wireframe. What we can see now is we can see yellow line work which is showing us where some of the patterned cuts we created earlier are. We can also see how we've cut in for the bearing each side, leaving that central cut of 22mm for the axle. Moving back to the sketch along the top of the tabs, we're going to create a line and drag across. Right click and click OK. This small line here is then going to have an arc created from one point to the next. So click from one edge of the line, drag across, click to the other edge of the line and drag up. And we're going to enter a value of roughly 15mm. To do this, choose the dimension tool from the ribbon, click on the arc and drag down. Click again and enter a value of 15mm. This sketch is now complete, so finish the sketch. And as you can see we now have a very small arc, semicircle, which we're now going to revolve to create a cut onto the surface. Choose the revolve option or the shortcut R from the keyboard, and under profile choose the small arc shape that we've just drawn. As you can see here it's shaded in pale grey. For the axes, what we need to do is find a suitable axis from the left hand side round which we can spin this profile. At the moment, again, the y-axis seems the most appropriate to choose, so I'm going to select the y-axis with one click. I'm now going to click to remove from the pop-up the remove material option or the cut option, and when we click OK, at the moment we can't actually see what has been achieved. So we're going to return to the view tab at the top. Under visual style I'm going to change it to shaded view, and now when I spin my model over, as you can see we've created a semicircled cut onto the top surface. In the model tree on the left hand side, if we now take the mirror option and drag it below the revolution we've just created, we've managed to change the order in which things are happening, but the model still remains the same. If I now right click on the mirror and choose to edit the feature, what I can do now, under the features option, click and add the revolution feature, or by clicking in the model tree and adding it. If I now click OK, what I've done is I've added the new feature so that it now appears on both sides. So we now have both the internal cut for the bearing and the revolution on the surface mirrored about that central work plane. Our last task before we move out of this file is to return to the model tree on the left hand side, right click and choose Eye Properties. What we're now going to do is, under the Physical tab, is simply apply a material suitable for this part. In this instance, moving from a generic material, we're going to choose an aluminium. So we'll choose the first aluminium in the list, select Apply, which will now apply the physical properties and the appearance properties. And when we return to our model, we can see that the model has now been rendered very quickly in an aluminium, and this part now has those matching properties.